In this video, we are going to work with equations with fractional exponents. Okay, when I say this, remember, when I'm looking at an equation, I always want to solve for x. Get x by itself. I see x to the 3/2, a fractional exponent. How in the world can I get rid of this? Okay, so remember, I want the x all by itself. Well, the reciprocal of 3/2 is 2/3. Watch what I'm going to do. I'm going to raise this side to the 2/3. But remember, whatever you do to one side, you have to do to the other. Now remember our rule. For power to a power, you multiply. So I have a power that's raised to another power. When I multiply 3/2 times 2/3, it is just x. X to the first. On the right side, 27 to the 2/3. You could type it into your calculator, unless your professor says no calculator. And then I'm going to rewrite this as the cube root of 27 squared. Remember, this bottom number is the root. So that's why that's a cube root of 27 squared. Well, the cubed root of 27 is just 3, because 3 times 3 times 3 is 27. Don't forget, you still have to square that. So x is going to equal 3 squared, or x is going to equal 9. Let's try another one. I have the quantity x minus 2 to the 1/5 equals -2. Now I can't separate that x from that minus 2 yet, because that is not x to the 1/5 or -2 to the 1/5. It is x minus 2 to the 1/5. So how can we get rid of that 1/5? Well, isn't that a fractional exponent? Couldn't I raise that to the reciprocal, as long as you do it to both sides? Okay, so the reciprocal of 1/5 is 5/1. So I raise both sides to 5/1. But 5/1 is just 5. So that's why I have just 5 here. Once again, the reciprocal of 1/5 is 5/1. And whatever I do to one side, I have to do to the other. Okay, so what happens on the left side? I have x minus 2 to the 1/5 raised to the 5/1. A power to a power you multiply. That will just be 1. I simply have x minus 2. On the right side, -2 to the 5th. That means -2 times -2 times -2 times -2 times -2. That would be -32. And look at this. It's looking pretty now. All I need to do is add 2 to both sides. My answer is x is equal to -30. Now, of course, you should always plug this back into the original equation to make sure that it does work. Let's try one more problem. It's looking a little bit more exciting now, isn't it? I have 64x to the 3/4 minus 125 equals 0. So I've got to solve for x. I see that x is raised to a fractional exponent. Let me get x by itself, and then I will deal with that exponent. So you should know how to do this. I'm going to get rid of this -125. The opposite of subtracting 125 is adding. Of course, whatever you do to one side, you have to do to the other. On the left side, I now have 64x to the 3/4. On the right side, I have 125. Now, don't start messing with a fractional exponent yet. The x is not by itself. You need to first divide by 64. But if you divide the left side by 64, you have to divide the right side by 64. On the left side, The 64s will cancel. I will simply have x to the 3/4. On the right side, that will not reduce. I will simply have 125 over 64. Now, I finally have my variable by itself, except for the fractional exponent, but you should be getting good at this by now. How do I get rid of that 3/4 in that exponent? I'm going to choose to raise it to the 4/3, the reciprocal. But if I raise the left side to 4/3, I have to also raise the right side to 4/3. The left side, power to a power, you multiply. 3/4 times 4/3 is simply 1. I have x to the first. That is looking good. On the right side, yes, I have to do a little bit of work. I could put this into a calculator. Make sure you keep that in parentheses. 125 over 64 raised to the 4 divided by 3. Make sure you keep that in parentheses. But that wouldn't be nearly as much fun as working it out myself. So I'm going to rewrite this using a radical. That is going to be the cube root of 125 over 64 raised to the 4th. Remember, when it's raised to a fractional exponent, this denominator here is the root. So I just rewrote this. It's 125 over 64 to the 4/3 is the same thing as the cubed root of 125 over 64 to the 4th. And so I can still do a lot of this in my head. The cube root of 125 is 5. The cube root of 64 is 4. But don't forget, it's still raised to the 4th. No, sugar plum. Now I do have to use a calculator here. I guess I really don't have to, but 5 to the 4th, well actually that's 625. I can still do that in my head. And 4 to the 4th, that is 4 times 4 times 4 times 4, which is 256. Okay, we can plug this back into the original equation to make sure that it does work. And hopefully you are a pro at equations with fractional exponents.